Mm-hmm. It's funny that it happens just like a minute after I solve the problem. Are we live? Yes, we are. And now the other question is, what happens with YouTube video? So did I finish a stream or not? YouTube. I don't want it to be treated as two separate streams. So the stream is live. The question is, what will happen after the stream with the whole video? Okay, so as I said, sorry about issues. For some reason my PC restarted in the moment when I turned the camera on. I think it shouldn't be like that. It isn't intended behavior, but it happened. And we are back now. What I need restream chat here as well. And if it's a new stream, okay, I wonder now, will it have a different link? Twitch should save the video, but now I'm not a partner on Twitch, so nothing is saved here. So I will not have the whole thing. FBM. So yeah, that's a new link in YouTube. And the previous one is now just a video that is already available. What happens in the last few seconds? Let's see. Yep. So that's bad. You may title the first one as a single problem stream. Yes, I think I can even download it, cut it to only that problem, to even remove the beginning when I had sound issues, because who would want to watch that? And I will just leave it as solving that single problem. The other thing is that I took a long time to solve it, and I had troubles with my graphics tablet, so maybe I will just remove the whole thing, or make it at least. I think nothing valuable happened there. So if this is a message for those who will watch later, if you're starting a stream now, or the video on YouTube, then there were issues with the first part of the video, and possibly even I will remove that one from YouTube, because nothing valuable happened there. Now, what I want to do, programming stream 4. I did upsolving, and now let's do some research online. Okay, I wanted to read IOI syllabus and to see what is unusual there. Syllabus 2018. Maybe this is. Syllabus 2018. Is this the same version? This is the syllabus version for IOI 2018. What is the difference? And this is what? Okay, I think I want official version with highlighted changes. So there are categories: included, unlimited, included to be defined, included unlimited, included to be defined, included not for task description. So this would mean that, for example, whether you need to know what are vectors to understand the statement at all. So the solution can involve something like that, but not the statement, at least not without explanation. Outside of focus, so we try not to do that. Excluded but open to discussion, and then explicitly excluded. What is the right way for a beginner to do competitive programming and become someone like you? You must practice. That's it. Learn new stuff, solve problems. Anything that is prerequisite of an included topic is also included. Okay. Included unlimited. Topics in this category are considered to be prerequisite knowledge. Contestants are expected to know them. Okay. Included but to be defined. Contestants should know this topic, but when it appears in a task description, the statement should contain a sufficient definition. This category is usually applied in situations where a general concept that would be included has many different flavors, and a formal definition is needed to distinguish among those. Example, directed graph. Okay. So both of these should be learned and known. Included not for task description. Topics that belong to this category should not appear in task descriptions. However, developing solutions and understanding model solutions may require the knowledge of these topics. Example, asymptotic analysis of upper complexity bounds. By the way, is audio good? Do we have any echo? Not everyone can become LGM. Yes, just like not everybody can become the best in the world in, I don't know, football or some sports. There is some talent to that. But you can be very good if you practice a lot. Topics that belong to this category should not appear in task descriptions. Okay. This is the main category that should be of interest when preparing contestants for the IOI. It should be noted that this set of topics contains a wide range of difficulties, starting from simple concepts and ending with topics that can appear in problems that aim to distinguish among the gold medalists. It is not expected that all contestants should know everything listed in this category. Okay, so everything with this OK mark, like that, should be known for participants. Then, outside of focus, any topic that is not explicitly addressed by the syllabus should be considered to belong to this category. Contestants are not expected to have knowledge of these topics. Most competition tasks will not be related to any topics from this category. So maybe this will be an alternative solutions. Examples of such tasks being used in recent IOIs include blah, blah, blah. Okay, art class was the problem about understanding from the picture what type of art it is, like modernistic and so on. Explicitly excluded. Okay, examples, calculus. Okay, excluded but open to discussion. Okay, the rest of this document contains the classification of topics. Audio is good, no echo. Okay, thank you. Integers operations including exponentation, comparison, basic properties of integers, sign parity, divisibility, basic modular arithmetic, addition, subtraction, multiplication, prime numbers, fractions, percentages, geometry, line segment, angle, triangle, rectangle, square, circle, point vector, coordinates in the plane, polygon, vertex, side edge, simple convex inside area, Euclidean distances, Pythagorean theorem, additional topics from number theory. So those are excluded but open to discussion. So what, like the, how is it called, Euclidean algorithm for GCD is excluded? In general, GCD is excluded because there is no greatest common divisor here. Is it excluded then? Then exclude geometry in 3D or higher dimensional spaces, analyzing and increasing precision of floating point computations, modular division and inverse elements. Okay, I'm surprised that this is excluded as well. And that's an important thing. Do I want to write that down? Maybe I do. Let's temporarily, I will do that in my streaming file. Yeah, Chinese reminder theorem, that I guess that is excluded too. What would be strange? So this is your syllabus. Excluded. Here I only want to write what is like the surprising stuff that is excluded. I wanted to do that. GCD, Chinese reminder theorem, modular division inversion, geometry in 3D makes sense, 3D, but I will write that down anyway. Precision issues, complex numbers, general conics, parabolas, etc., trigonometric functions. Okay, trigonometry, so sinus, cosinus, discrete structures, functions, injections, inverses, composition, relations, sets, inclusion, exclusion, complements. Okay, cardinality and countability makes sense. Basic logic, truth tables, quantifications, modus ponens and modus tollens. What it is? What is it? P implies Q and P is asserted to be true, therefore Q must be true. Okay, so just understanding ifs. Normal forms. What is normal forms? Ordering logic. 1NF. I remember 1NF and 2NF. What was it? So I remember I've heard about it. Okay, maybe I will check that out later. Validity, limitations of predicate logic. Okay, proof techniques. Okay, basic of countings. So Burnside is excluded. Solving recurrence relations is excluded. Okay. But included is, for example, inclusion, exclusion. So included, inclusion in exclusion principle. So I'm writing down what is important to remember that is included or excluded. For example, I would say that GCD is easier than inclusion-exclusion principle. Then binomial theorem. So, well, what is binomial theorem? Okay, this one. So basically, combinatorics are okay, but solving of recurrence relations is not, and Born site is not. So here, Born site, and here I will just write combinatorics. Graphs and trees. Normalization. Normalization meaning what? Changing length to 1? Okay, so 1 and f and so on is normalization. So I don't know what that is. Database design technique which organizes tables in a manner that reduces redundancy and dependency of data. Okay, that's enough for me. I'm not interested in that. Trees, undirected graphs, blah blah blah, path cycle, handshake lemma. Spanning trees, traversal, so BFS, DFS, decorated graphs. Okay, multi-graphs, graphs with self-loops, bipartite graphs, planar graphs, and then hypergraphs, perfect. Tree width, expansion, planarity testing, finding separators, okay. Discrete probability, applications where everything is finite and thus arguments about probability can be easily turned into combinatorial arguments are question mark, everything more complicated is excluded. So this is possible, but not just included, possible. Yeah, question mark was outside of focus. Outside of focus. Discrete probability. Maybe it should be between included and excluded. Other areas in mathematics, geometry in 3 or more dimensions, okay? Linear algebra. So matrices are excluded. Linear algebra and matrices. I wonder whether matrix exponentation can be possible. Inversion, Gaussian elimination, okay. FFT, calculus. Okay, NIM is excluded. NIM, calculus. Functions. So basically, understanding language is important and included. Debugging strategies, properties, correctness, efficiency. Now, data structures. Strings, static and stack allocation, linked structures, graphs and trees, the existence of precision issues, pointers and references, okay, and then what is outside of focus is data representation in memory, heap allocation, runtime storage management, using fractions to perform exact calculations. Okay, this is an important thing. So outside of focus. Non-trivial calculations on floating point numbers, manipulating precision errors. So yeah, that was excluded here. Precision issues. Recursion. Do you have small algorithms like finding inverse module in a repository, or you manual code it in contest? Finding inverse I do just by hand. Some harder stuff like FFT I copy. But I don't know, trees, any type of trees I do by hand. Geometry, most of geometry I do by hand as well, unless it's very hard, then I copy. Recursion, divide and conquer. Okay, event-driven programming, what is it? Dialog with reactive environment, okay. Algorithm complexity. Little o, omega, theta notation. Tuning parameters to reduce running time, memory consumption, or other measures of performance. This is outside of focus. Makes sense. Asymptotic analysis of average complexity bounds. Well, average is not so important usually because we care about worst case anyway. Using recurrence relations to analyze recursive algorithms. Okay, so this is repeated again. Makes sense. Algorithmic strategies. Outside of focus. Heuristics. Finding good features for machine learning tasks. Discrete approximation algorithms. Randomized algorithms. So this is outside of focus. Outside of focus here. Clustering algorithms. Minimizing multi blah blah blah. Algorithms. Simple primality testing. So maybe the Ross Pollard is not here. Pollard's raw. Okay. Prefix sum, histogram, bucket sort. Simple string algorithms. Quick sort and quick select to find the k smallest elements. Traversals of trees. DFS, BFS. Euler paths and cycles on a tree. Euler's tour on a tree. Connected components, shortest path algorithms, Dijkstra-Bellman-Ford Floyd-Warshall MST, two algorithms. Bipartite matching. I scrolled to the top. Bipartite matching in O V times E. Bridges, articulation points, strongly connected components, basics of combinatorial game theory, winning and losing positions, minimax algorithm for optimal gameplay. Okay, so NIM is excluded, but game theory is included. I will, I think, copy that. Basics of combinatorial game theory, winning and losing positions, minimax algorithm. Minimax. Max flow is excluded. Oh, I marked everything bold. I didn't want to do that. Exclude optimization problems that are easiest to analyze using matroid theory. Matroid intersections, okay? Lexicographical BFS, maximum adjacency search and their properties. Data structures, find an union, BST, so included BST, BAT, Fenwick, augmented BST, LCA, persistent data structures by path copying, nesting of data structures such as having a sequence of sets, trees. So I will copy that. I'm not sure if I understand that correctly. Excluded. Excluded are string algorithms and data structures, such as KMP. Heavy light decomposition. KMP is excluded. Then heavy light decomposition. Separator structures. Okay, what about centroids? Are these centroids? Separator structures? Because there are something that is called separators in trees that are something else. Data structures for dynamically changing trees and their use in graph algorithms. Okay. Excluded. Heap variants such as binomial and Fibonacci heaps. Okay. Using and implementing hash tables. So maybe understanding hash tables. Two-dimensional tree-like data structures, such as two-dimensional statistically balanced binary tree or a tree of trees used for 2D queries. So 2D trees, again, wrong button. Fat nodes and other more complicated ways of implementing persistent data structures. Distributed algorithms out of focus, basic computability excluded, P and NP doesn't matter much. Grammars, understanding a simple grammar, I guess it's just the most basic notation. Formal definition and properties, final state, regular expressions, okay. Amortized analysis, online algorithms, randomized algorithms. Online algorithms are out of focus. I think it's very a common thing. So alpha beta pruning, cryptographic algorithms are out of focus. No, they prefer integer arithmetics. Okay, and no. Everything up to here. Sweeping line, convex hull, coordinate compression, polygon contains a point, computing the area of polygon, intersection of two lines, turns, yeah, nothing interesting. Point line duality is excluded, half space intersection excluded, okay, but convex hull is included. Coordinates of circle intersections against lines and circles. Programming center of mass. Okay, this is excluded, some physics. Well, linear algebra sometimes helps you understanding what points move to which place. Makes sense. Parallel algorithms are out of focus. Other areas, I guess nothing interesting for us. Testing. Okay, that's it. So these are things that weren't obvious for me. Hi Errichto, congrats on Nutella. Thank you, Nicola. So we have that. Not that I needed this list right now, but I also give classes to high school students who prepare for Olympiad and then for IOA, and I would prefer to know what is included, what is excluded. Then let's go through this file a little bit. Yeah, so this is important thing, but it shouldn't be in bold. Okay, change stream name, boring programming stream to algorithms could forces competitive programming stream. I think the current thing is fine. Yeah, Git repository is done. New Gmail and browser accounts. Nope. Switch to Windows. Yep, to do. Night mode in IDE possibly. Find the mod later. Stop doesn't matter. New account in Polygon will do. Write alt editorials. Okay, still to do a little bit, but not today. Add timestamps to lecture another time. Use some sound filters to do. Echo. Okay, so this is mute desktop audio. Code forces frequently asked questions, so some of that was done. Figure out the camera position and size. Well, I'm doing that every time anyway. So this eventually, I guess I will have a space in my apartment to stream all the time. Right now, every time I just set up everything from zero. I was going to read about this, figure out sections in the Google Doc, well, whatever. Figure out glitches. Still to do. Open, yeah. Address stream chat. Change Twitch description. This is like should be done every time. During boring streams, finding good cool problems for YouTube videos, answering some code forces comments, reading various tutorials, materials, and what is nicely explained. This is what I'm going to do now. In stream, put problem name in the top, not this type of stream. Remember about removing be right back. Yes, I can do this. Nope. I can do that. But where's my be right back? Yeah, I have be right back. Check comments every few minutes. I'm doing that, I think. Okay, channel plans. This shouldn't be bold. This shouldn't be bold as well. Stream ideas plans. So these both Polish National Olympiad is done. Google hashcode is done as well. So I don't have anything more here. And this shouldn't be bold and it shouldn't be crossed out. Private to do. Okay. I think I can do that now. Make my own template for an ordered map. Okay, so let's do that. I mentioned in the last boring stream, and this will be later. I mentioned in the previous boring stream that An ordered map should be used in code forces with our own hashing function to avoid hacking, and also it's better to use the C++ map because it's slow. So favorite blocks in code forces. In code forces, I marked some blocks as favorite. Petrozavodsk camp. Why is it in Russian? I guess they forgot to translate it. Usually only on the Russian version of site you will see Russian announcements. Favorites. I want to read this one and this one and create my own template. Congrats on legendary GM. Thank you very much. Faster hashtags. So I'm going to implement this myself and like try this myself and do some benchmarks and like add it to my templates. Better hash function. Okay. So let's do that in B. So I will put that later in my GitHub repository, for which I think the link is in the description, both in YouTube and Twitch. And now let's work on the file ACPP. What do I need? I need to measure time. Do I want two separate files? Yeah, it's okay. So okay, values. Let's say that n is 1 million. Values pushback rand modulo whatever 2 to the 22 or maybe the 40. Repeat 100 times, create an ordered map or set. Is it both about sets and maps? Hash tables. What do we compare with what? It's about maps. So from int to int, just m. Now for everything in values, plus m of x. Now for everything in map, let's say the answer will be the sum of squares. Of the numbers of occurrences. Time, and it takes a lot of time. Let's for now decrease that to just one iteration. half a second, 10 iterations, and this should take around 5 seconds. What if I use a map? And the map turns out slightly slower, or even a lot slower. Now if I use this, so a map was 2 times slower. If so I need GP hash table. And instead of 5 seconds, I got under 1 second, which is amazing. Of course, I should test also like reading a lot, finding values, but I believe that this was tested well in this blog. Now about hash function. It's just the identity. What about this? If let's try to break this program. Choose to use prime table sizes as done here, or choose a better hash function for integers. So hash standard resize policy, hash prime size policy, okay, or use a different hash function. I guess that we need to use a different hash function with this time since epoch, because someone could hack it. One weakness of hash tables is that many people can find the hash collisions offline and blow up the complexity of your hash map. Let's try that. And then I will call that special hash. And here special hash. But how to remember about using it all the time? That is a hard thing. What about now? Still very fast. And this is not perfect either. Choose a better hash function for integers. That looks more complicated. Let's see. I wonder whether it's slower, but it's slower only by a little bit, so I guess that's fine. The question is whether it's safe. Make unique char get. What this is? Make unique of char get. Does it read from the input? I don't understand why is it not just the other thing. So just this. Make unique of char constructor. So like an empty constructor on char and then get. Oh, it's like it's a position in memory, I guess. So it's an extra thing, but I do not need that. I think just time since epoch is enough. Let's print that. So this is a huge value. So these are like something like nanoseconds. Okay, what previously there was is what XOR, and how big this is. Okay, so this is also it's not stronger in any way. So I think I will remove that from my implementation. Even if it is in templates, I don't want that to be very long. Okay, random is that. And now I have two randoms. I don't need two randoms. Shouldn't this be static? No. Okay, maybe not. Hash combine. Is it used in any place? Now, does something happen when I remove that? Nothing. So what is hash combine? Maybe it's for hashing pairs. Let's see if this is something in C++. C++ hash combine. Something in Boost is called hash combine. Okay, if I want two things and to combine two things like what, a pair, then I need that. Just doing this would be weak, I think. Okay, can I use here a pair? I can't, and if I have that, I still can't. Yeah, well, maybe let's do here make pair, just to make sure. And here I have pair instead of a single int. Return hash combine of x. Nah, what do I have here? It should be something like hash combine of hash f of x first and hash f of x second. Now it makes sense. But then I can use add this hash combine myself, or just here write this times 31 plus b. So I don't think I need hash combine function unless I need it. Okay, so I will remove that. Pairs first times 31 plus second. And this should be strong. I don't like the fact that I don't fully know what this code does, but I hope someone smart wrote this. And it's for sure harder to hack. Okay. So I think I will copy this to my templates. Now, can I use unordered set the same way? So first maybe make using GP hash table easier. Then can I use unordered set this way? So it's very easy to forget about this special hash thing. Also, let's call it my hash. So I want to do something equivalent to a define, like my hash table of something will be GP hash table of something and my hash. Okay, and how to do it with types def or defines or whatever. This can be a list of arguments, that isn't a big deal, but I would prefer to avoid using define. Okay. So template of class, or just struct, whatever, class T and class T2, T1 and T2 will be I don't want to create a function. Someone better in C++ should do that for me. Maybe I will leave it this way for now. And just now let's investigate, can I use unordered set this way? So this was GP hash table. Does someone here mention a set? Custom hash set. Okay, what about this? Someone said that max load factor which means for unordered map to reserve some memory already. So to create a lot of buckets, what helps hash set a lot, then it will be fast, maybe even faster than that policy hash tables. Custom hash set, so always custom hash set is fastest. Maybe I should just write my own hash set and use it instead of this GP hash table. But this hash set isn't much faster, maybe here on this one machine on Windows. So using that didn't seem to do much for that person. Okay. XOR random is not enough for a safe hash function. Then here is the safer function. So I guess I'm using this one. Okay, but this is a bit different, so let's compare that. Indeed, random is better to be made static inside this function. It doesn't have to be here. Then this is the same. I like this version better. I can remove that. The operator. Okay. Now this can be changed to just fixed random. Okay, let it be fixed random. But the line is long. So maybe because the line is long, I will stay with the first version. So I will move this here. Random. My hash. Okay, so I need to do that inside the function. Yep, I need to. I guess the difference will be that here I create something else for every struct. So for every set I would use a different random. I don't see any downsides or advantages of that. So what do I prefer? Static can be here, but then the line is long. How long? 94 lines, characters. Okay, let's say I prefer version with shorter lines. Let's make sure that it works and it works fast. Okay, let's stick with this version. Can I use unordered set this way? So I guess we can't, because the block would mention that otherwise. Hash table. So, but still we can use that. Okay, I can compare also these to just use sets. So here let's print the number of different values and size. Nine 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 529. Okay, and now what about a set of int? Insert x. It's slower, and unordered set. It's slower as well. So lesson is, if possible, just use this special new hash map. Of course, such a thing will not be able to do lower bound. Okay, I think I will add this to my templates. Maybe not to templates. I will keep that in my GitHub repository so I could copy that, find that easily and copy it. This should be what? Hash map? Just map CPP. Hash table. What is the best name? GP hash table CPP. You can write using chrono steady clock to make that line shorter. Interesting. So let's this can be closed. Well, let's not close that now. I can write this line shorter. Steady clock. Oh, I understand. Can I use? But I don't want to. If it's not necessary, I don't want to add using here, because maybe later in code I will reuse something from chrono. For example, using this, I think, would mean that now is now a keyword. I couldn't name something now, so let's not do that. But thank you for a suggestion. It makes a lot of sense. So still git commit. And I can even push that. Okay, I think you can see it now in my GitHub repository. So things like that I want to keep in one place, and I think it's okay if I do it in my repo. Also, you are free to copy that and use it. Just don't assume that it's for sure correct. You saw how I modified that. Maybe I did a mistake. Maybe something is wrong here. I don't really understand that function, but there was a link to that, to the description of that. This can be removed. Okay. I will try using it from now on, and I can unmark these two blocks. I also marked some strange segment tree to learn about it later. So this is done. Then none of this should be bold. For some time recently I didn't do videos on problems. Because I didn't have time or will. I think we'll move to this point. So I would like to find good materials for various topics. Let's start just with Gaussian elimination, and I want to see how much time it will take me to find different materials. So algorithm Gaussian elimination, and I know this elimination, or is it called Gauss elimination? Just want to see how is it explained online. In particular, the important thing is precision issues. So how do they deal with that? Let's start by reading Wikipedia explanation. It would be nice to find such a tutorial that maybe doesn't use words that a reader doesn't have to understand. A matrix can always be transformed into an upper triangular matrix. I guess we must understand that, because this is what Gaussian elimination should achieve. Definitions. Multiply a row by a non-zero scalar. Swap the positions of two rows. Add one row to one row a scalar multiple of another. I think a good explanation would use words that are used in school. So for those of you who don't know what this is about, basically when you have a system of equations, and again, so now I can't draw with tablet unless it's fixed. Yep, it isn't. Maybe it will work now. Doesn't seem to. So now it magically works. So when you have a system of equations like 2x plus, I need slightly wider pen to make it nicer. 2x plus y is 5 and 3x minus 5y is something. Let's say it's 1. Then there are different methods to solve that, and Gaussian elimination just takes numbers from the equation. First equation is described by numbers 2, 1 and 5. The second one is 3 minus 5, 1. Yes, you're right, Sarah. Let's maybe read that. Let's write that in a table, maybe, or just so it would be visible what is under what. 2, 1, 5, 3 minus 5 and 1. This is a matrix or a table, two-dimensional table. Now we can do some operations on that table, like what we would do with equations. So we can add two equations to each other to say that from these two we get 5x minus 4y is 6, and some other stuff too. Generally, if we want to find x and y here, the easiest, most straightforward thing that will always work, if possible, is Gaussian elimination, where we try to get rid of this element first. So to do that, we multiply this second equation by 2 times 3. So instead of doing this, we transform this to times 2 divided by 3. So this would be transformed to 2x minus 10 divided by 3y is equal to 2 divided by 3. So this was times 2 divided by 3. And now you can subtract these two equations to get an equation for y. So 1 minus 10 over 3, which is I think minus 7/3, y is equal 5 and 2 by 3, and then from that you can get y. The same can be done here with a grid, where the algorithm is for every column to find the first non-zero character number. Then for every other row with non-zero in this column, so for example this one, we do this row minus equal 2 divided by 3 times row number 1, because it's allowed when we solve this system of two equations, and we'll get 0 here. We'll get a new matrix that is 2, 1 minus 5, or 5, and then here 0 minus, I guess, 10 over 3, and something, 2 over 3. Then in the second column we try to find the next non-zero element other than the row already considered. So this is fixed, this we treat as fixed, and this row is, let's say, protected. And then here will be in the next column, this is the number that we want to take, this one. And again, thanks to that, we'll change this value to 0, and thus we'll get something like y is blah blah blah, x is y blah blah blah. Well, blah blah is a number. So how does Wikipedia explains that? They define row echelon form. If the row does not consist of only zeros, then the leftmost non-zero entry is called the leading coefficient. So this was that fixed number. If two leading coefficients are in the same column, then a row operation of type 3, so subtract one from the other with some multiplier, could be used to make one of those coefficients 0. Then by using the row swapping operation, one can always order the rows so that for every non-zero row, the leading coefficients blah blah blah. Okay, so we can get a form like that. And here we have an explanation of what algorithm does, where for every next column it finds the first non-zero. Now, how should I research all of that? Should I read it carefully? Should I go through that? My goal is to find good materials about Gaussian elimination. Now, how to do it? Possibly not to make it very boring. So, Gaussian elimination. What else do I have? Practicing Burnside's lemma. Yeah, maybe I will do that later. Is there some explanation in code forces? Expectation of a random variable. Okay, this is something harder. Maximum source upset. The thing with this is that we divide by something, we multiply by non-integers, so there will be precision issues. Modular prime. Okay. Emacs English. Do they have something on Gauss here? Gauss and system of linear equations. Given a system of linear algebraic equations, check if there are no solutions, exactly one, or infinite number of solutions. If there is only one solution, find any of them. If it has at least one solution, find any of them. This method can be used to solve the equation modulo any prime number p. Hello, Errichto. Hello, Bluefog. So, today you missed issues with audio in my Linux system, and the solution was to turn off desktop audio right here, just so you would know what else cannot work in Linux. Okay, overview. And right now I'm reading about Gaussian elimination to see what website describes it best. It is possible to exchange two equations. Any equation can be replaced by a linear combination of that row and some other rows. Okay, so I guess this is bad formatting. they wanted to put this in a new line and then this in a new line as well. Can I change that? Okay. Well, it would be good to improve that a little bit, at least that formatting while reading. In the first step, Gauss-Jordan algorithm. Okay, so it's called Gauss-Jordan algorithm. The described scheme left out many details. At the ith step, if AII is 0, we cannot apply directly the described method. Instead, we must first select a pivoting row, find one row of the matrix where the ith column is non-zero, then swap the two rows. Yeah, we check where we are looking for the first element that is not 0. We swap rows, not columns. Yeah, if in your algorithm you swap rows with each other, then the issue is at the end you don't remember which thing was which equation, depending on what you're trying to do and print at the end. In many implementations, when AII is not 0, you can see people still swap the ith row with some pivoting row. Yeah, we can get two big numbers. By the way, it's hard to choose non-zero element. So if something is 0.000001, should we treat it as 0 or not? Precision issues are huge, and here, and also you will get big numbers sometimes. Because you add the other row multiplied by something, and that something can be big, and if you start with numbers up to 1 billion, after one move I think the values can be up to 10 to the 18, then 10 to the 36 I think, and so on. Maybe not 36, I'm not sure, but they can get bigger and bigger exponentially. The generate cases, implementation. Choosing maximum value in the current column. Yep, so if we don't want to choose some special epsilon, to say if this thing is greater by absolute value than 10 to the minus 5, then we can do, we can choose maximum value in the current column. The complexity is n cubic, if n is equal to m, the sizes of grid. Acceleration of the algorithm. But this will reduce the number of operations by half. So it's still n cubic. Doesn't matter. It's not complexity. And here they describe the same algorithm with base 2, what means that each number is 0 or 1, and then you can treat rows as like bit masks, and you can XOR them when you want to subtract one from the other. Then the solution will be 32 times faster. Practice problems. So this is a good algorithm. I think generally cp-algorithms.com or just Emacs is a good source tutorials. Now, do I want to get through the Wikipedia article? What about this Gaussian determinant? They will just tell us how to find a determinant. Okay. So for competitive programming, I think this website will be the best. Well, this is more like for linear algebra classes. This says nothing about the precision issues or implementation. Oh, there is an algorithm that avoids precision issues. Algorithm to calculate the determinant of the echelon form of a matrix of integer entries using only integer arithmetic, and divisions that are performed are guaranteed to be exact. No reminder. The method can also be used to compute determinant of matrices with approximated real entries, blah, blah, blah. And then the complexity is so n-cubic operations, but every operation deals with big numbers. They said that here, I guess. Arithmetic complexity of n-cubic has a bit complexity of n to the 5. Because numbers made in the process can be huge, but not so big. I wonder whether it is very hard to implement, but they don't even provide a pseudocode here, so I guess it's complicated. I can close that, I guess. Maybe I don't have to. What Gaussian elimination tutorial. Because I have issues with desktop audio, maybe I will not watch YouTube videos about it. Dummies.com. So this is, yeah, many websites will implement that in terms of maths. So because usually students in linear algebra classes need this algorithm. Competitive programming. Geeks for geeks. Let's see. They define the row echelon form, reduced row echelon form. So I think this tutorial is bad because it says nothing about how it works for equations. So I would like something that says, okay, if you want to solve 2x plus y is something, 3x minus 5y is something, then one of the possibilities is that we try to get rid of this term, and it should describe what we do with equations and then how it looks like when we modify this grid. So I think that this is an example of a bad block, that it just describes the algorithm without giving some motivation. What about this one then? Overview. So this one is also bad in that term. We need a CP wiki. Most of the things will be generic, but there. What I would like to do is try to find just good resources online and be able to point to them. If I decide to create a new website that will have materials, it will be just like with that that comic of XKCD. Situation. There are 14 competing standards. We need to develop one universal standard that covers everyone's use cases. And then situation is there are 15 competing standards. So I think the same would happen with a new CP wiki. There were ideas like that. I guess that this website is best there is. And there is a lot of harder stuff there. So what else do we have? Hacker Earth tutorial. Okay, for sure it's good to add stuff like this is a technique used for, and then solving linear equations, finding determinant, and so on. If you don't remember it, have a look at this video. Where is a video? There is no video. We will be applying the same technique to solve a problem, but I don't want a problem explanation. I need a block about the technique. No, so this isn't a block about Gaussian elimination, I think. And this is not a link to some. So he posted a link to the main page of his blog instead of the post about Gaussian elimination. Then article from 2007. Okay. So more drawings would be better and in better format. So this is just bad formatting. So another, I guess, thing is that it should use LaTeX or something else and to show examples. Wikipedia is nice in terms of that because it shows you what happens exactly. And this is a plus. So Wikipedia article would be nice, but it doesn't say anything about the competitive programming aspect or about precision issues. Well, here I think they lack an example to talk about the algorithm in cpalgorithms.com. Gaussian elimination is just raw operations on the coefficient matrix for eliminating one variable at a time. That's true, but I don't know what. So I agree that Gaussian elimination is that, but what should we do about that? So is it bad, good, or what? Do I speak Russian? No, only a very little bit. I can read letters in Russian, the Cyrillic alphabet. So I think an example from Wikipedia is nice, plus the description from CP algorithms. What else? I googled Gaussian elimination and I got my video here. But it's of course because the browser understands my history and that I would click that likely. That's it. So for competitive programming, the best two resources are these ones. Maybe now it's time for me to read it all to see if there are some mistakes. Let's open the The document. Now, okay, here there was IOI syllabus, a new page. So here I have, maybe I need a new document for that, or maybe not. Good materials online. Materials or tutorials. Then Gaussian elimination. Example explained. Here, competitive programming aspect. So, programming precision and stuff like that. Okay. I can have slightly greater, slightly smaller margin. Code forces, Gaussian elimination. This also says something about like bitmasks version right here. That is also good. Programming precision. Modulo 2 version. And also I think they mentioned that it solves modulo NEP here, what is important as well. Confused by the stream title. Will you show how to shoot a Gauss rifle today? So I guess you must check what is Gauss elimination, unless I made a typo in title. Yeah, so elimination is about, I guess, eliminating non-zero elements. I'm not sure about that. I can close that. Okay, so here they explain with an example. That is nice. Maybe this is also valuable. Okay, so they don't say at all. Okay, explanation. Given matrix representing following equations, there's a unique solution for given equations. Blah blah blah. Do they explain that this should be written as a grid at all? So here, that was that matrix. It isn't that bad, but I would guess that Wikipedia and Emacs versions are better. Let's leave that for later, and now let's check out some other topic like segment trees, knapsack. Okay, so how are segment trees explained? I don't know, on Wikipedia, segment trees. In principle, it's a static structure. That is, it's a structure that cannot be modified once it's built. Okay, that's strange. Segment tree for a set of n intervals uses n log n storage? Why not O of n? So segment tree is maybe not what I know as a segment tree. Maybe I want to read about interval tree. You can just rewrite Wikipedia. Well, improving materials online will take a lot of time. I can't just, or we can't just improve everything. I know that Wikipedia can be modified, but it takes a lot of time. So let's focus on finding the best what there is in the internet. Okay, this is certainly not what I think about. It allows one to efficiently find all intervals that overlap with any given interval of point. So nope, we're looking for segment tree, but I don't know what they do that they have n-log-n storage, and that they say it can be modified later. So they have a set of segments, they split them by endpoints. Okay, so they have, in every node they want to store all the intervals that are below. This is not the competitive programming segment tree at all. Yeah. So this is not our segment tree. Segment trees tutorial. Let's see, Hacker Earth tutorial. There are multiple range queries on an array and modifications of elements of the same array. So this is what our segment trees are about. For example, finding the sum of all elements in an array from indices L to R, or finding the minimum, famously known as range minimum query, problem of all elements in an array from indices L to R. These problems can be easily solved with one of the most versatile data structures, segment trees. I'm not sure if it's good to add a word easily at the beginning of some block. Binary tree used for storing the intervals or segments. Each node represents an interval. The root of t will represent the whole array. I think it's complicated. That I think it's better to say that n. Let's assume that n is a power of 2. Right now, this tree is harder to understand and to work on. I think we should say that an array is padded till it has a size that is a power of 2 with zeros, and then we work on that. Apart from competitive programming, what is other field of computer science in which you work or interest? I am just in competitive programming. Okay. The root of tree will represent the whole array. Each leaf represents a single element. The internal nodes in the segment tree T represents the union of elementary intervals. Okay. Why do they repeat this? The root of T represents the whole thing. The root represents the whole thing. Then it is broken down into two half intervals or segments, and the two children of the root in turn represent the blah blah and blah blah. Oh, then they have a very hard segment tree. And this description doesn't match what the drawing says. Or it does. Yeah, it does. They split 7 into 4 and 3. So they have a very complicated segment tree. They want to, if they will do what they describe, for something of size 6, they will connect them in this pattern. Then the same thing here. And this is very hard to process and to know what, like, it's hard to store this segment tree in an array. If you use pointers, then it's fine. But let's read that till the end. Doing a perfect binary tree is much easier. Yep, exactly. So it's better if the number of leaves is a power of 2. Or at least that. So for 6, what I would do, if we want their format, is then say that the left child of a root is a full tree of size 4. Then here our right child has that, and just here we don't have something, but this is still easy to process and to think what is my parent, what is my left child, right child. Yeah, I think this is better, but let's continue. In each step the segment is divided into half. The height of the segment tree will be locked to n. There are n leaves representing the n elements of the array. The number of internal nodes is n minus 1, I agree. Total number of nodes is to n. Once the segment tree is built, its structure cannot be changed. That's correct, but it's better to work on a perfect binary tree so that the structure would be trivial. We can update the values of nodes, but we cannot change its structure. Segment tree provides 2 operations. So it's unnecessary here to think about structure at all, I would say. Segment tree provides 2 operations. Update the element of the array A and reflect the corresponding change in the segment tree. In this operation we can query on interval or segment and return the answer to the problem. Say minimum, maximum summations in the particular segment. Makes sense. Implementation. Interesting. Am I interested in machine learning and artificial intelligence? So I tried machine learning and I didn't like it much. AI seems nice, but it's related to machine learning. No WF, it's only neater to explain. It's not better during implementation at all. So Teddy, do you mean that perfect binary tree is better or worse? Or what? Not better during implementation at all. Oh, so you don't agree with me and you're saying that indexing with, like, treating it as a perfect binary tree is not better during implementation? I don't agree. Because so here they use an example where the left child is anyway a size of 4, so they got lucky, maybe on purpose. But here in this example with an array of 6, if we want, how do we want to number the vertices? It's hard to say. If this is 1, 2, 3, 4, 5, 6, 7, what if this will be 6, 7, 8? 1, 2, I messed up. 1, 2, 3, 4, 5, 4, 5. If we do just in the order row by row, number with consecutive numbers, then the children of I are not 2i and 2i plus 1. It's completely messed up. Simple linear array can be used to represent the segment tree. So they want to use linear array. array, but then it's better to treat it as a perfect binary tree. Before building the segment tree, one must figure what needs to be stored in the segment tree's node. If the question is to find the sum of all elements in an array, then at each node, except leaf nodes, the sum of its children nodes is stored. Okay. Can be built using recursion, bottom-up approach. Start with the leaves and go up to the root and update the corresponding changes in the nodes that are in the path from leaves to root. Leaves represent a single element. In each step, the data of two children nodes are used to form an internal parent node. Okay. For update, search the leaf that contains the element to update. And how do they want to do that? This can be done by going to either on the left child or the right child, depending on the interval which contains the element. But this is very hard. If we have a perfect binary tree, then we know exactly where a leaf is. Leaf number 3 should be accessible in position the power of 2 plus 3. That power of 2, that is a base of a tree, the n. As long as it is a power of 2. Once the leaf is found, it is updated, and again use the bottom-up approach to update the corresponding change in the path. So this part is unnecessary if we have a perfect binary tree. To make a query on the segment tree, select a range from L to R, recurse on the tree starting from the root, and check if the interval represented by the node is completely in range. Return that. Okay. So this is not a full. I think this is not enough for an explanation, if for someone who doesn't know segment trees, but it's fine. Also, for them, even they don't store leaves in one layer. This node is a leaf. That's unusual. But I guess that indeed their memory will be 2 times n. What sometimes can be almost 2 times better than my version, where I expand an array to be of size power of 2. Take an example. Okay, return the sum in interval. So, by the way, if you write constraints like 0 smaller than L and so on, put them after defining LR. Don't say given end LR do something such that blah blah, and then people will parse this part together. Return the value of this sum such that L smaller than R smaller than N. Then it doesn't make sense, or it will completely change a problem. Queries and updates can be in any order. Naive algorithm. Using segment tree. Okay, so they built it recursively. So let's think how they will number stuff. Okay, here there's an example for 6 vertices, and the numbers will be 1, 2, 3, 4, 5, 6, 7, then 8, 9. Here we skip 2 values, 2 leaves. Then this was 6, so these are 12 and 13. So they don't have a better memory. Here they don't use some 2 cells, so they waste memory as well. Start from the root, recurse on left and right children until a leaf node is reached. Okay, so, but at least it's correct. To update an element, look at the interval in which the element is present and recurse accordingly on the left or the right child. We repeat a lot of operations here. So it's bad that to find a leaf with an element, we need to go from the root, and also here in a function for update, we need to do that, like find the middle element of an interval. By the way, we don't have to check that, I think. Assuming that we are here already in interval from start to end, then for sure we will not be on the left from start. In the end, can you show us your implementation? When I'm solving any problems, you can see my implementation. But mine isn't, I think, best to explain to beginners, because I do everything iteratively, bottom up, which is not so easy. When I teach someone, I explain them recursive version as well. Just, updating something here, I think, is better to do iteratively. But then this splitting into intervals, this part, I do iteratively because it's faster, but it's harder to explain. So I would prefer to also use this version. But this is just terrible. If we do that for a perfect binary tree, it's how many lines? Let's close that. Whatever, some temporary file. I didn't want to close that. So if I want to change ti to x, then, and I have some base is power of 2, then to do this I have for int just whatever is base plus I, or maybe 3 of base plus I is x, then for a from base plus I divided by 2 up to 1, so a path to the root, 3 of I is like max, let's say that this is maximum tree. And this is the whole implementation, this like what, 4 lines, this instead of this long thing. And it's not hard to understand if somebody will tell you that vertex v has children 2v and 2v plus 1, then a vertex v also has a parent v divided by 2. It's easy to remember, it's easy to draw trees thanks to that, because you know exactly how it will look like. So also analyzing what happens is better, I think. Okay, let's finish reading. So we move to left child or right child. We move and then, okay, we merge in the process, but it's also not so easy to understand. I think, so something like that I explain only when I'm talking about lazy propagation trees. That we need to go to children and then merge in the same function. Complexity of update will be log n. Yeah, and it's not so obvious that this will be log n, while it's obvious here, more obvious. Query on a given range, check 3 conditions. Range represented by node is completely inside the given range. It's bad to reuse words like range represented by node and given range. It would be better to say that the given range is LR and then use here LR. If the range represented by node is completely outside, simply return 0. Why 0? Oh, we are talking about the sum in interval. If the range is represented by a node if the range is completely within the given range. And then it's bad to here say something and then just here they copy paste that. They should just explain it once. Return the value of the node, which is the sum of all the elements in the range. Okay. Start, end, LR. And I hate the fact that it's so easy to mess up start, end, and LR. So what is the difference between start, end, and LR? I named them, I think, low, high, and query low, query high. So the interval coming from a query. And this is hard to understand. No, this is fine. Yeah, this is fine. Return that. Okay, and here, well, brackets are unnecessary. So generally, a block is, I think, well explained. I just don't agree with the idea for this kind of splitting. I would do that on a perfect binary tree, but the block is well written, I would say. So that was the first one. What else do we have? What are some good tutorials on segment trees? Okay, so there are many of them. This is why it's stupid to write yet another one, because there will be just now 14 of them. So one more and there will be 15, like in XKCD comic. Okay, efficient and easy segment trees. Let's read that long blog that I saw multiple times. Segment tree with single element modification. Modify one element in the array, find the sum of elements in some segment. Perfect binary tree. I like to visualize a segment tree in the following way. Makes sense. Imagine. Makes sense. Notation is node index, corresponding segment, left border included, right excluded. Okay. A drawing of a tree would be nice, for sure. It will be so hard to choose the best tutorial, by the way. I guess each of them will have some disadvantages, some nice things. At the bottom row we have our array, 0 indexed, the leaves of the tree. For now, suppose its length is a power of 2. 16 in the example, so we get perfect binary tree. When going up the tree, we take pairs of nodes with indices 2i to i plus 1 and combine their values in their parent with index I. This way, when we're asked to find the sum of interval 3, 11, we need to sum up only values in the nodes blah blah blah, marked with bold. Not all 8 values inside the interval. Let's jump directly to implementation in C++ to see how it works. Array size. Modify. Build a tree. Okay, I don't like using something like that. It's very language dependent. So other languages don't have that shift by 1 binarily, and people will not understand this. It's much better to just use 2 times I. Here I would use 2 times I plus 1, and it's not slower, it's the same for compiler. So I find this implementation hard to understand, especially for people not familiar with C++. modify. Okay, and this is very hard to understand for people not familiar with C++, and like the it's not so important to make the code so short, especially in a block that explains something. So here we increase p by n, and then we start with something. Instead, after this line, I would say p plus equal n, and then start from something. So there is no gain from making this one line, especially in a block that explains something. The compiler already optimizes to bit shifts if they are faster, so no need to write this way. I agree, Bluefog. If there is a difference, then it's like 1%. Doesn't matter. But I think there will be no difference. Okay, then query, what we do here. And this is the iterative implementation. So I use the same thing, just in a different way. I don't understand why he does L++. L+1 would be enough. No, because later he will anyway divide by 2, so it doesn't matter. So can he just remove that part? This does nothing. Oh, he wants to get to the next L. So if L is odd, like 7, he wants to increase it by 1, so he would be to another value. Okay, so this is important, but tricky. I think my version is easier. Okay. So how I would write something from L to R is, let's say I've read that, and I'm looking for the sum. Then I write L plus equal base, R plus equal base. Sum is plus equal 3 of L. Now, if L is equal to R, then we are already done. So either we can do this, or just if L different than R, then sum plus equal 3 of R. Now I want to add everything in the middle, and this is a tricky condition that I don't like in my implementation. But so this means there are still numbers between L and R. If L and R are different by 1, then there are nothing in between. If I'm the left child, let's do it as one liner for now. Sum plus equal 3 of L plus 1. If R is the right child, sum plus equal the other child. And this. And I can visualize that. Sketchpad, here it is. So what I do is given, for example, interval from here to there. So this is L, this is R. This is L and this is R. Then I take the sum from this node, and then I go up from both. And every time, if L was the left child, then I also add the right child, and then move on. Here R, if R is the left child, then I add, no, if R is the right child, so here you do nothing. Then when we are in this vertex, I'm the right child, so I add this. Similarly, left one will add this. And here, when we are in these 2 points, then there is nothing in between. So this is empty, and the while will not continue. So I've split it into these vertices. What is slightly suboptimal, so still the complexity is logarithm, but instead of this L, taking L and the right child separately, I could take a parent. Then again, instead of this one and this one, I could take a parent. So this here I lose a few operations. Not necessarily lose, because I anyway go through a tree, but I wouldn't have to read this thing and this thing. What if I wanted to make it faster? At the beginning I would do minus minus L and plus plus R, and then I wouldn't have that issue at all. But I think then the reason for it to work is harder to understand. So I take L, I take R, and then I want to take everything in the middle. So when I go from R here to up, I know that I'm right child of my parent, so the left child is between me and L. So I add this to the answer. What do we have here? Some problem. So can you talk about the problem above? I deleted dot from HackerRank as I wasn't allowed to post link in the chat. So what is this problem about? Why should I solve it? Is it related to segment trees, for example? Then I prefer. So your nickname matches the conversation about segment trees, LRRR1. I prefer L is this, R is that, and then sum plus equal plus 1 divided by 2. But how so L plus 1, but still we must here check if L is not equal to R, right? Can you provide like a few more lines of your implementation? And the other thing is that I know a lot of people that use just like in this block. Let me close the Gaussian elimination. Just like in this block, I didn't want to close that. They use open intervals closed from one side and open from the other side. So inclusive from left, exclusive from right. What makes sense. I don't like that, but it's reasonable for sure. How long have been solving problems? Right now, for a few hours. This stream is going, and in my life for a few years, 7 years. Let's continue reading this. Follow a personal example. Leaves are stored in continuous nodes with indices starting with n. Element with index I corresponds to a node with index I plus n. We need to build a tree. Okay. Modifying an element is also quite straightforward and takes time proportional to the height of the tree. We'll need to update values in the parents of given node. Okay. Sorting by one moves to the other child. What makes sense? Here I could use, maybe my implementation would be easier if I did that, because this moves between the two children. Okay, maybe that's a better implementation. Finding the sum also works in logarithmic time. To better understand its logic, you can go, for example, with interval blah and verify that the result is composed exactly of values. Well, this is not a good explanation. I think we should show with a drawing what happens. If L, the left interval border, is odd, then L is the right child of its parent. Then our interval includes node L, but doesn't include its parent. By the way, all of that should be its without apostrophe. So we add TL and move to the right. No recursion and no additional computations like finding the middle of the interval are involved. Yep, this is a plus. We just go through all the nodes we need, so this is very efficient. Arbitrary sized array. For now we talked only about an array with size equal to some power of 2, so the binary tree was perfect. The next fact may be stunning, so prepare yourself. The code above works for any size n. Whoa. Explanation is much more complex than before. So let's focus first on the advantages it gives us. Segment tree uses exactly 2 times n memory, not 4 times n like some other implementation offer. Array elements are stored in continuous manner. All operations are very efficient and easy to write. You can skip the next section and just test the code to check that it's correct. So I'm not going to do that. For those interested in some kind of explanation, here's how the tree for n equal to 13 looks like. Okay. But 13, 1, 2, 4, 8. I see here only 10 leaves. So these are also leaves, I guess. So first leaves are on the right. Okay, makes sense, but it's trickier. Maybe the disadvantage is that in harder implementations, so also something where both queries are about intervals, it's harder to check if something is a leaf. When I want to check if something is a leaf, I compare that with n. Okay, but this also works. So starting from index n to up to 2n minus 1, we have leaves. So that's good. Maybe my implementation would also work without the power of 2. That's very nice. Why were you looking at IOI syllabus? Do you plan on conducting training camps for the same? Yes, I teach in high school, let's say. How did you prepare mathematics for competitive programming? How did you prepare? So I had very strong background after school. In primary school, high school, I was very good in maths. I did a lot of, I participated in Olympiads. Now here we have here we have implementation by LRRR. So, as I said, I don't like a line like this. While L smaller equal R, L is this, R is that. If L is not left child, so if L is right child, then we do that. Okay, makes sense. So it's equivalent, but again, I think tricky to think about. So on the other hand, so there are many different versions of segment trees, and I guess that if somebody understands some version, that version will be easiest to understand for him. So I understand this one, and for me, mine is easier to understand, but it is subjective. Let's see the chat for now. No preparation needed. High school, pre-college level maths is generally required. Whatever else you can learn when solving problems. That's more or less true. Given an integer array of size n and q operations, there will be 2 types of operations. Update. So you don't have to, Romeo, copy the statement here. I asked you, you gave a link and I asked you, is this problem about segment trees or what? Like, it was enough to say that there are queries and maybe it is about segment trees. I can check it out later. But if it is on HackerRank, then there is an editorial. Like, that's not sure. Okay, so there is no editorial. The other thing is that it's good to solve problems that have editorials. So I might check that out later. Let's finish the block. I won't bother with formal proof here. Modification on interval single element access. All we need to do in this case is to switch the code in methods modify and query as follows. Okay, and we have some push. If at some point after modifications we need to inspect all the elements in the array, we can push all the modifications to the leaves using the following code. After that, we can just traverse elements starting with index n. This way we reduce the complexity from n log n to O of n, similarly to using build instead of n modifications. Okay, I get it. So this is in case at the end we want to print the value of every leaf, and we can do that treating the query thing as a black box that works in logarithmic time. Then we will get n log n, but instead we can push everything down, and again, so this is very hard to understand. Just write 2 times I here, 2 times I plus 1. And this looks terrible. So I shifted to 1 or 1. Non-commutative combiner functions. So some functions are harder to update. Addition is very easy and we can reverse that, we can do anything. Which means the order of operands doesn't matter. We have A plus B equal B plus A. The same applies to min and max. But don't forget to initialize query result to infinity instead of 0. However, there are cases when the combiner isn't commutative. For example, in the problem this tutorial available here. Fortunately, our implementation can easily support that. We define structure S and combine function for it. In method build, we just change plus to this function. Yeah, so I have a similar thing. So did he use structs first? S. No, he didn't. So I do a similar thing. So I gather stuff on the left and right. To combine that. Makes sense. And final, lazy propagation. Technique to perform both range queries and range modifications, which is called lazy propagation. Okay, I'm not going to read that because there are a lot of extra stuff, and I just wanted to find the best block about segment trees. And generally this one is very good. So I think prefer power of 2 because it's easy for me to draw a tree to see what happens. But on the other hand, a tree is smaller, so it's easier to debug in this case. And drawings of trees would be nice. What happens here? Yeah, somebody asked why there is no contests for a week. I think it isn't something unusual. So do we want contest on Codeforces every 2 days? It's impossible. So that was this very competitive programming algorithm. I don't like operations like that. It's very hard to read that if someone doesn't write in C++. And I see no advantage of writing it this way. And other than that, it's slightly different than my implementation, but this is still fine. Oh, the other thing I would change is I would move this outside the for loop because it's harder to understand, or this one, it's very hard. Just make p plus equal n, and then t of p is equal value. Unless, so making it this way makes sense only if you want to squeeze maybe the space in your like reference document from which, with templates from which you copy code. But 99% of people shouldn't do that, I think. And this is not faster to code than just writing p plus equal n, then t of p is equal value, because the number of characters is roughly the same. It's just that this version is one line, what doesn't have advantages. Okay, what else? So I should also check videos out. Refer to this excellent post. Okay, let's see the excellent post. There is a lot of code, but I guess it's because there are examples to different problems. Let's go through this block. And the list of problems is also nice. It is a height balanced tree with static structure. What is height balanced tree? What does word height mean here? Oh, I guess I understand that the height is balanced. Okay. The nodes of segment tree correspond to various intervals and can be augmented with appropriate information pertaining to those intervals. It is somewhat less powerful than balanced binary trees because of its static structure. Okay, so when Wikipedia said about static structure, they meant that how the tree looks like can be modified, but the values can still be changed. Okay, so previous tutorial said that it's easy, and this one is incredibly easy. In a segment tree, I think we gain nothing by that, by writing that. Only there is a probability that some participant will not understand something and will feel stupid. On the other hand, I think that sometimes we should use word that something is easy in the middle of the editorial. If we want to skip some proof, then it's just an information whether we indeed skip that because it's easy or because it's hard. Just to, like, it's called, I think, a sanity check. But it doesn't, there is no advantage of writing at the beginning of block, this will be easy. Given I find the index, given I find the index greater or equal I with blah blah, do you do that problem with segment tree? No, I wouldn't. But if you want, in Codeforces I said something about I wrote frequently asked questions, and in particular I think I will make that in bold. I explained why I don't help with problems without sources, at least I try not to. Provide a source of your problem. If there is no link and the person is not well known in the community, I am assuming it's from an ongoing contest or it's your homework. I think such blocks should be answered too, but not immediately. So write a block with your question. Yep. I know that on the other hand it's inconvenient, and it would be easier to ask me something like that. I'm not sure what I should do with such questions. Should I answer them immediately? But then what happens if there is an ongoing contest and just people come to my stream and will ask me questions from those contests? So I think it's safer if I generally try not to answer such questions. So you can give me a link to a problem. Just like the previous guy did, remove a dot so that YouTube system would allow you to paste a link. Or go to Twitch. I think in Twitch you can paste a link. So actually I'm going to edit that and make this in bold. Preview. Yep. Okay, so but then the formatting is screwed. How to fix that? Let's refresh. I want to edit it again. Edit. This should be. Can I put just this stuff in bold? Will it work? It doesn't. What about putting the starting markers here? Now nothing is in bold. Maybe the point will not be in bold, but the words will be. By the way, since I wrote that blog, I think I was able to link that to someone 30 times. I get a lot of questions in priv. Okay, that is better. So I will just give a link and say the part in bold. Awesome. So what are we doing now? I'm checking out this block. The over tree is complete binary tree of height n. The diagram shows how the binary tree is built up and how the nodes are indexed. Given a node with label I, its left and right children are to I plus 1 respectively, and nodes. This is not important here. The fact that parent is I divided by 2 is important. However, sectors are the most effective when you think of them as just a recursive structure. Consider a segment tree with n equal to 3. As in the above figure, 15 nodes. Every node represents some interval. Now assume you need to make a query on some arbitrary interval in the array. The most straightforward way would be to look at the lowermost level in the segment tree, but that would require as many operations as there are elements in the interval. Well, so he's saying we can go through leaves. Congratulations for LGM. Thank you, Pravesh. Now assume that you need to make a query in some arbitrary interval, blah blah blah. For example, if one desires to query the interval 2 to 7, this would mean having to look at the nodes blah. But we can be smart and choose only nodes 3 and 5. The former takes care of the interval for 7, while the latter takes care of 2, 3. So it will be nice to see a drawing that shows this tree also with intervals marked. 2, 3 should be somewhere, for 7 somewhere. Just to reiterate that, I guess one thing I want to do is find best resources for every topic. The other is to learn what makes a block nice. So what should be done better. The exact implementation is detailed in the rest of the article. Sectree can be described by these 4-dimensional operations: merge, split, update, single subtree. Add to it binary search, and almost every variant of sectree that I have come across can be broken down in terms of these operations. What about push down to the lazy propagation? At the end of this block, I will give a STL-like packaged version of sectree. Basic idea. The internal nodes summarize the information stored at descendant leaves, so that the information about all the leaves can be extracted quickly. That's a very important thing in sectrees. The merge operation does this task of summarizing the information stored at 2 nodes into a single node. The internal nodes store the operations that have to be applied to its descendants. Okay, but that's more complicated. I think it's better if we first explain sum tree, the basic one, and then add stuff like something that should be applied to descendants, so propagated down in a lazy manner. This is more complicated and should be explained later. Update single subtree, split operations, propagates this down the tree in a lazy manner. Yeah, so I don't like that the basic idea contains all the ideas for all the versions. Report minimum. Oh, now we have something new, because here we have minimum instead of the sum of elements. Choose a value of n equal depth of your tree equals ceiling of logarithm of the number of nodes, but he didn't define m. Yep. So m, I had to guess what is m, so that all the array elements can fit at the lowest level of your tree. The merge function for this problem does exactly what you think. It will just take 2 values and return the minimum. So the first operation that is required will be taken care of by merge itself. The second operation requires us to modify one of the leaves of our tree. There are 2 possible approaches: update the leaf, then notify all its parents in the tree to update the information. Also, this is approach A. Struct node. Okay, so here we use structs. Why do we need add? Why do we need split right now? This is too complete. So this is already with pushing values down, what is too complicated. The basic versions shouldn't have that. So, okay, so this was fine, but I think the block should start from basics and only add then extra stuff, especially like in this case, in segment trees, where it's possible to first describe the basic tree and then say, okay, we can augment that by adding more values. Prince of Persia, everything about segment trees. Okay, let's read that. that can be a good block as well. It's very long, but I think the basic segment trees will be described in the first paragraphs. In this lecture of algorithm gym, data structures. Okay, partial sum. That is something that I should eventually read. So let me add that to favorites. It works? Works, okay. Classic is the way I call it. This type of segment tree is the most simple and common type. In this kind of segment trees, for each node we should keep some simple elements like integers, booleans, etc. These kind of problems don't have update queries on intervals. Example 1 online. For each node we keep, okay, so let's see what it is. I don't like the fact that we take as an example something that is not trivially segment tree. But then for each node we keep 3 integers: answer for interval, the number of opening brackets, the number of closing brackets. I don't like the fact that we start from unless this is about just solving. Maybe this block, data structures, contains a description of segment trees. Heaps, red-black trees. By the way, red-black trees, if I remember correctly, are excluded from the IY syllabus. Square root decomposition. May you suggest any other way to make any topic strong apart from practicing problems from that particular problem set as you know the topic? So it gives a big hint with cracking the whole problem. Yeah, that's a good question. The disadvantage of solving problems for some topic is that if you go through some problems, they will be on that topic. So there is no part when you think which topic it is. This is why solving random problems and participating in contests is important. And this way you will practice also thinking what should be applied. So I guess this will just come with time if you participate in contests and solve random problems from recent competitions. Okay, Fenwick, segment tree, yeah, segment tree. So this image is not available. So another lesson is don't upload images not to cut forces, because I guess this was the thing here. I think I can write down some general advice. So at least in my opinion, what is important. Drawings. Starting from the most basic examples and versions. Then don't start with this topic is easy, like it's unnecessary. What else? Try to make code short instead of not short, make easy to understand instead of one-liners. Okay. And upload images to the website, to Codeforces, instead of other other hosts, because then something like that can happen. Something was here, but we don't know what. Root of the tree belongs to the interval. It doesn't belong to the interval. It represents or corresponds to. Each node has 0 or 2 children, left and right. If a node's interval is this, the interval of its children will be L mid, and this, well, mid is the half. Each node has an index. Root is 1. Children of x are 2x and 2x plus 1. Segment tree could have up to 4n nodes. Yep. To split an interval to some nodes of this tree will act like this. This is not a good explanation. So if somebody doesn't understand segment trees, he doesn't understand what this talks about. What splitting intervals? What intervals do it split? So this is not a good block, I think. Not a good description for beginners. What do you do as a profession besides being a CP pro? I sometimes teach at workshops or programming camps. I organize contests. Any good resources for DP plus the bitmask for beginners? Not yet, but I think I will have some in the future. I think I will have a lot of time the next week, and then maybe even a few days in a row I will do those boring streams where I research good materials, so that when people ask me good resources for DP and bitmask for beginners, I will be able to point to good resources. This is my goal here. For example, for Gaussian elimination, I recommend now a Wikipedia page with description of algorithm, but it will not talk about competitive programming aspect, and then reading CP algorithms, so Emacs description, where they say something about precision and version modulo 2 or modulo P. Now, so I guess this is best so far. I don't recommend the the one from Hacker Earth, because it is very strange in terms of what is child of what. Geeks for geeks. Find the sum of elements and change something. Did I read that? But anyway, this tree is terrible again. I prefer a perfect binary tree, at least in this way. So for now, this one wins, but it has no drawings. Segment trees. This, but no drawings and code hard to read. So maybe there is no good tutorial about segment trees. Segment tree tutorial. Let's try to find a better one. And also I will grab something to eat. Okay, so Emacs has a, maybe English version of Emacs has a tutorial. CP Emacs English. Do we have segment tree? Yep, we have segment tree. So let's read that. Okay, so next step will be checking out this. And let me grab something to eat, and I will be back in I don't know, max 3 minutes. So now I can put this beautiful sentence, how to call it, box with words. Okay, now I'm back. Hello, Ozdi. Good to see you. So we are researching good materials right now about segment trees. I must remember to turn off, be right back. Do you know Ukonen algorithm? I heard about it. One of my ICPC teammates knew what it is, and it's enough. Sounds like some string algorithm. Okay, also what I wanted to do is finding some, so this will be to do later, will be finding some Gaussian problems for Gaussian elimination, because I'm going to do a lecture in my class for high school tomorrow about that, and I need to find some not trivial problems. Somebody in Codeforces suggested me one problem, but its statement was so long. Maybe I will check that out later. By the way, well, what do I have here? It's a Nutella jar that I got yesterday as a gift. Of course, it's not a coincidence. Here's one. Okay, I will check that problem later. Thank you, Mkaisik. How much can I prove in 1 year? Currently 4 star on Codechev. So let's say you can get to 6 stars, but you must practice a lot. And if you want to see very big improvement, then you must spend something like 20 hours a week, I would say. Then in 1 year you will be much better. So while eating, I will read this Emacs tutorial about segment trees. By the way, for some topics, maybe the best tutorials for competitive programming will be in Russian. There's nothing we can do about that. Well, we can translate that. I don't know Russian well enough. But Yandex Translate is very good in translating Russian to English. Okay, introduction is fine. Simplest form of a segment tree. And yeah, that is a good thing that they start from something simple instead of saying we can also push down and stuff like that. To start easy, we consider the simplest form. We want to answer some queries efficiently. And also handle changing values. The segment tree should be able to process both queries in logarithmic time. What is a segment tree? What am I taking right now? If you're asking about what food I'm taking, so eating, then it's sandwiches with Nutella. And otherwise, I don't understand the question. So it's again not a perfect binary tree. It's the same version that was given 0, 1. Okay, it's yet another version because on Codeforces the leaves were numbered from this one. This was 0, 1, 2, 3, 4. Here they have 0, 1, 2, 3, 4. So it's completely another version. and I like the drawing because it says everything, what is the sum and what interval is considered, is represented here. Appreciate what you do. I'm glad about that, Amina. From this short description of data structure, we can already conclude that a segment tree only requires a linear number of vertices. Well, it's not so trivial to see, maybe. The first level, yeah, so then they say why. The first level of the tree contains a single node. The second level will contain 2 vertices, 4, and so on, until the number of vertices reaches n. Not exactly n, something smaller than n. And thus the number of vertices in the worst case can be estimated by the sum, blah blah blah, which is for n, okay? So for now we're forgetting about a case with not power of 2. The height of the segment tree is logarithmic because the size of segments decreases approximately by half. Okay. What level do you know about mathematics? I'm very good in mathematics up to high school, and I know most of concepts from university. Does the rule of 10,000 hours of practice hold in competitive programming too? Yes, it does. So there is a rule. If you want to master something, you must spend 10,000 hours. And it's true for many things, and it's reasonable also for competitive programming. I think that I'm close to 10,000 hours in competitive programming. It's hard to say because on some weeks when there were training camps like Petrozavodsk, then I spent easily more than 10 hours a day on competitive programming. Then during a week it would be maybe close to 100, which is crazy, but it's only for programming camps. Other than that, well, while practicing for ICPC, we had maybe on average two trainings per week, which is 10 hours itself, plus talking about solutions, upsolving, so 15 hours. Then during a year, it would be 50 times 15, because there are 50 weeks in a year, which is what, 750? So easily 1,000 hours a year while practicing for ICPC, and a bit more than that. I would say that I have like 6,000 hours in my life trained for competitive programming. Or there is a way to work smart. Of course there is. So in everything you can work smarter and more stupid way. But solving problems and learning new algorithms is a way to go. So for leaves we copy values of AI. Okay, they described how to build it. Maybe here a code would be nice, because this is a bit abstract, and so first recursively construct the two child vertices and then sums up the computed sums. So they want to do it recursively, just like some other algorithms. I think it's easier and shorter to do it iteratively, but that's fine. Now some queries. When you start explaining segment tree, so I'm not going to explain segment tree from zero. I'm researching good materials about it. Of course, while I do that, you can also learn a little bit, but my goal isn't to teach you segment trees, also because most of you likely know segment trees. Maybe I will do a lecture about that, what is quite easy for me because it's an easy topic. But now I'm just checking how others explain that and what I think is a good way to explain it, what is a bad way. So we are currently in vertex that covers the segment TL to TR. There are 3 cases, as usually we consider 3 cases. I wouldn't say that the case with equal intervals is something special. Generally, if we are completely inside the interval, then it's one case. Okay, they're saying how to go to only one child. The segment of the query can fall completely into the domain of either the left or the right child. Then we go to only to that one. We can do that, but I think it's easier to go to every child and then a child himself will check whether he is outside the interval. The speed is slightly worse, but it's easier to implement. Okay, so they overwrite the interval from a query, what makes sense. Then because of that, here they compare with the interval instead of checking am I inside the given range given in the query. So every block so far explains a different approach, what is a very strange thing. I didn't even know that there are so many ways to implement that, to approach that. The calculation of the query's traversal of the tree, which spreads through all necessary branches of the tree and uses the precomputed sum values of the segments in the tree. That's a good description. We start from the root. Okay, the bad thing about this implementation, I think, is that it's harder to understand. I'm not entirely sure about that. It's hard for me to say because I know segment trees. Maybe we would have to do some voting, some poll among people that don't know segment trees. They should be presented with both approaches and then they should say which one is better, because here they're talking about some recursive approach, while this editorial gave a shorter iterative version, just similar to the one that I do in contests like Code Forces, but I think it's harder to understand. I think it's better to go with a recursive function from the root and to decide whether we are outside or not. Also, this recursive version will be possible later to modify to work with lazy propagation. Well, I guess he in this block needs to later explain it from zero, right? Lazy propagation, push, build, query. Okay, so here he said something about lazy propagation, but he still uses recursive version. I'm not sure how to do it. Okay, so here we have apply. Why is it apply and here it's modify? Shouldn't he call itself? So applying to something else. Okay, I would have to read through all of that, but I guess then he must introduce the recursive version. What is bad? It's better to immediately explain this one part that is anyway easier thanks to that, so that later we could say now we should add a few more things to that recursive implementation and it will be able to do something more. CS Academy had some lessons. Maybe they also described segment trees, and they have some visualizations. Right. So maybe this is a way to go. It's even possible here to set custom input so that this video would show us what happens for that particular input if we don't know what would happen there. So maybe this is the best explanation. Let's check that later. Okay, but back to Emacs first. I think this is too small example to show what happens. How often are problems about F50 in the contest? I don't know, you can go through recent problems from Codeforces and see how often F50 tag shows up. Maybe once every 20 hard problems, I would guess. Why is the complexity logarithmic? Okay. I wonder what is the best way to explain why the complexity is logarithmic. They show it by induction with a very long paragraph, but there should be, I think, an easier way, a shorter way. I would say that on every level, at most two intervals, at most two nodes can intersect but not fully with the interval from the query, and from those two nodes we will go to both children, and in any other node we will stop. And that's the end. Let's read what they said here. Let's assume that we visit 3 or 4 vertices. This is unnecessarily long. I don't like that explanation. I think it's too detailed, too complex maybe. In conclusion, the query works by dividing the input segment into several subsegments for which all the sums are already pre-computed and starting the tree. And if we stop partitioning whenever the query segment coincides with the vertex segment, then we only need logarithmically many such segments, which gives the effectiveness of the segment tree. Okay, now updates. They again use a recursive function. I don't like that. Let's see the implementation maybe. We only start the sum in the array, yeah. So the thing about having arrays is that we don't have to store those pointers to parent, children, and so on, as long as parent of I is I divided by 2, children of I are 2i and 2i plus 1. Thanks to that, we save a lot of memory compared to the solution with pointers. Maybe it's bad that I'm trying to, instead of just reading this, I try to explain it myself, and this is fine, but my goal was to check whether this tutorial is nice, to see if I like it and if I should recommend it to others. So we are creating an array of size for n. I like to create that dynamically, so create a vector of just size 2 times power of 2, because I find that power of 2 that is greater than n. So we build recursively. I prefer building iteratively. Then I don't like the fact that we have TL, TR, L, and R. Again, this is hard to understand which is which. It's easy to mess up. Then update query. This is not very efficient. So I showed why I prefer iterative update, because it's just 4 lines. and there is nothing squeezed here. Just like this is how I would write it, and I don't see how to write it in any longer way, iteratively. Then advanced versions. Okay, I don't like this implementation, so I think still the best one is the one on Codeforces. Maybe I have a bad version myself, because my version is half iterative, half recursive. I only answer queries when I explain it to others. I only answer queries recursively about an interval, while updates and building is iterative. Maybe it's better, for better understanding, for easier understanding, to do everything in the same manner. Then it's either everything iterative or everything recursive. Okay, so that's done. Now, what about, so let me check some problems out. So this one is about, let me read it. I'm looking for some problems on Gaussian elimination. The statement is complicated. The first belt generates a second belt such that each cell of a second belt at the same time counts the packets in some 5 cells on the first belt. For example, in the first cell of the second belt sums the packets in cells blah blah blah. The second cell of the second belt so the second belt, for every cell in the second belt, it is the sum of some 5 cells from the first belt. And then let's do a drawing. There is first belt, then second belt, and every cell in the second belt is the sum of some 5 cells. Let's say 3 ones, and also this one is the sum of some 3 cells, and so on. A third belt is generated in the same manner until the nth one. Since the number of packets on the belts usually increases, the number of packets in each cell is observed only modulo this number, which is, I hope, prime. Let's see. Factor. Yep, it's prime. So in Linux, factor gives you the factorization of a number. As the winner of the golden ticket to the factory are able to see how the nth belt looks like. Trivia has also explained you the production process, and now you're wondering how first belt looked like. Okay, so we are given these edges between 2 consecutive belts. We know every edge, every cell comes from which cells. Okay, so because M is huge, the first thought is to do matrix exponentation because we are given a matrix of like how we go from one belt to the other. To know how we go from first belt to the last one, we should do matrix exponentation. The complexity will be log of m times n. What is time limit here? 0.2. That might be too slow. Maybe it's possible to use the fact that we only go to 5 new cells. I'm not sure. And I have my last sandwich with Nutella. By the way, it's very nice that Codeforces doesn't have a contest for 5 more days, because I can't mess up. And so at least for this week I will be Nutella. So then after we do that matrix, I can say this word, exponentation, I think. We'll have, I guess, a sequence of equations that will say from this cell of the first belt to this cell of the last belt we have multiplier that one and so on, what will be just a series of equations. Maybe I will code that to see if it passes in time limit. And also in Codeforces, somebody gave a link to a different problem. I managed to go through the statement, what wasn't easy. And in short, so we are given some numbers in binary system. We want to choose as many of them so that there would be no subset that has XOR 0, which means in algebra that they are linearly independent. So we should do Gaussian elimination and then choose some independent subset of them. Then we also must maximize something. We have some, for every element initially, also we have values red and blue, and we should minimize the sum of taken red times the sum of taken blue, what seems very complicated. And so it is reasonable, but looks very hard, and I don't know how to do it. Maybe I can focus on that a little bit later. So first, this problem here, I think I will just implement the solution. Also, I will implement, we must print n integers, what means that when doing Gaussian elimination, I must keep track of where every row goes. So instead I will just say that I don't switch rows. I just will remember which one is already fixed, so is set to 0. Yep, so let's implement this problem just after I'm done with my sandwich. And this problem, yeah, as I said, it's hard. It's so easier version would be just given a bunch of points, choose some of them, then sum them up. So find the sum of, let's say we are taking 3 points and took this 3. I take the sum of their x coordinate, the sum of their y coordinate, and I want to minimize the area of this rectangle, where this is the coordinate of this point. Is the sum of x, comma the sum of y's. And this is on the top of the whole thing about Gaussian elimination. Actually, I think if I will find an editorial for this, I will just go to the editorial because it looks hard, and it was division 1 level 3. There were what? There were 4 solutions in C++. Wasn't this like very hard? So this is SRM 526.5. What seems to be a hard SRM. And this problem had 5 solutions. Oh, and 0 of them were correct. So nobody solved it during a contest, what means that certainly I want to see just the editorial for a contest. Because likely I will just now waste an hour. From where can I really understand bottom-up DP? I don't know. My goal is to find good tutorials about everything. Like, now maybe I know what to recommend for Gaussian elimination. I'm not yet sure about segment trees, but let's say that the code forces block is the best. Though my version is different. I wonder how to here use the fact that there are only 5 transitions. It doesn't matter for matrices. Are there some comments? Nope. And of course I wonder about the time limit, because we need to do modulo, so we will have n cubic operations times log of m, and each of those will be with modulo. Unless we do a trick, I can avoid modulo if I multiply everything on longs in n cubic and then just do for every cell modulo. So it will be n cubic multiplications and then n square modulos. That should be fast. And what about other problems for Gaussian elimination? Did some of the blogs that I checked out have some problems about it? Practice problems. The first one is very standard, just looking at the name. So we given a set of numbers, we must choose a subset that will be we'll have the biggest XOR. This is extremely standard. Then night moving, what it is? There are k blocked cells. No, that so our knight should go from 0 0 to xy. It can get from the current cell to cell plus ax plus ay, or this one. So it has 2 possible different moves. And I don't understand this sentence. Note that our knight may continue to move after he reaches the cell xy. How? So there are infinitely many possibilities if he can still continue. Unless he can't reuse cells. Okay, is up to 15. By the way, the fact about blocked cells reminds me of an AdCode or DP problem that I solved in the last minutes of the contest in my recent stream. But this is something different, I guess. I still don't understand why the answer isn't infinity. Do we have a limit for the number of moves? Oh, because only these two moves are possible. So unless we can't make a cycle, we can't move from xy and then go back. Okay. Okay. The question is whether this is just a problem with two equations, because what matters is the number of steps that we take before, like number of steps of the first type and the second type. What happens if there are no blocked cells? Then so these possible moves represent two vectors. Let's for now assume that these are not collinear, so they are linearly independent. In a drawing, this would look like, okay, so if, for example, one vertex is like that, sorry, vector, not vertex, the other like that, we want to reach this point from this one, then for sure once we'll use the vector going up and two times we'll use this other vector. One time and the other time. Let's assume that we wanted to get here. And the number of ways then to do that, if we must A times use one vector and B times the other vector, B times the other vector, then it will be A plus B choose A. This is simple combinatorics. Choose A. This will be the answer. But there are blocked cells. What other things we need to consider? Well, possibly, it's possible to make a cycle. This is possible if one vector points, for example, up and the other down. Then, if we can make at least one step, by the way, can values be negative? I think they can. If we can do, or also, can x and y be 0? They didn't specify that. So theoretically, x and y can be 0, but I hope there is no such test. Maybe also a question, do they have editorial? Yes, they do. So if they are in opposite directions, then we should see whether we can move forever. I hope that is easier to do. otherwise, finding A and B here, I guess, is easy. You don't need Gaussian elimination for that. But also, you have those K-blocked cells. But assuming that the vectors aren't collinear, it should be done in the same way as the adcoder DP problem. So just it's DP in K square. I don't understand why that wouldn't work. So so spoilers, if somebody wants to think about it, I'm opening editorial. So I would just do it in something like K square. Knight can make two kinds of moves. A and B are linearly independent, so it's described here. So they deal with forbidden points by using inclusion, exclusion, or Gaussian elimination. Approach free sorting. By now we know that the points in Q are ordered, thus so approach free. So here they find a way without Gaussian elimination. If this is some solution to a problem, I don't understand why they are describing these two. The points in Q are ordered. They don't even have to order them to make it work. Numbers of ways, not touching any Q. Number of ways reaching destination minus number of ways reaching destination touching at least one point. Number of ways of reaching destination touching at least one point in Q is blah blah blah. Yeah, so this is a huge overkill. Sutter solution. I see that Sutter solution asserts that values are up to 1000, while the statement said it was up to 500. He could create functions and constants for that, by the way. Okay, I don't want to read that. I think this is a stupid problem for Gaussian elimination because it's an overkill if there's a solution like that. Just similar to adcoder one. So let's close that. Then here I have to log in, no thank you. And I heard about snakes. I heard about this problem. I think I've read it once. The constraints are small, and for such small constraints it's possible to implement something that will work on doubles. At least I hope so. There is a board game, Snakes and Ladders, and what I guess it will be about probabilities, the maximum expected number of turns. So when you have a graph, a directed graph, and from every vertex you go to one of its neighbors with some probability, you can write down those equations for expected values, and you'll get a system of equations that where every variable is the expected time to get to the final cell from this cell. And by doing Gaussian elimination you can solve the problem. So you can find the expected value of going from cell 1 to the last cell. But to make sure, I will read the whole problem. If someone reaches a cell with a bottom of a ladder, he goes up immediately. If they get to head of snake, they go down by a snake. From a cell X, you roll a die, getting a number from 1 to 6, and you advance that many cells forward. And also we, how to call it, we get back from 30 if we didn't get the exact result. If we are at 28 and we rolled 5, then we go 1, 2, and then back 3, 4, 5. So standing 2 cells from the finish, which is cell 30, standing 2 cells from the finish, you must get exactly 2 to get to the finish and not get back, which is a bit harder. Now Toby wants to know how long will it take his game before it ends. He asks you to compute the expected amount of turns they rolls before he wins. It is guaranteed that it is always possible to reach the goal of the board and that the maximum expected number of turns will not exceed 100,000. The starting cell will never be the base of a ladder and the target cell will never be the head of a snake. So the number of cells, so the number of variables here will be up to 100 something. The board also is not like, it will not be of size 2 times 3 or smaller, so that it would be possible always to get back from the finish. To like bounce, I think that's the correct word. S is the number of directed edges, so the snakes and ladders. Print the answer with this probability. So this is not a completely good, I think, problem. We still can get huge numbers. Even though they say the answer is up to 100,000, which is the expected value to go from cell 1, it's possible that from some other cell the answer will be huge, even infinity. Because maybe there will be some cycle. For example, from 1 you will get quickly to 30 because there are ladders from cells 2, 3, 4, 5, 6 to the top row, and you will easily get to 30 quickly. But maybe from a cell 8 you can only get by a ladder. Let's say there are snakes. After you move from 8 to one of the next 6 cells, there are snakes that will get you back to 8. And then from 8 you have infinite cycle, and the answer from there will be infinity, what might mess up your implementation of Gaussian elimination, which is bad. I'm not sure that the solution by organizers is correct, but there is no way for us to check that. The question is whether tests are strong. But it's something anyway. Okay, so we had those 2 problems, and I'm going to find the problem for okay, I was going to read this as well, and then I need an editorial for this. So editorial for 5 to 6.5. Let's find top coder editorials. This was some time ago. No, thank you. What a nice system that I have to scroll down and down. Okay, maybe I can just Google editorial of this round. Top coder editorial 5 to 6.5. It was div too hard. Okay, so there is no editorial to this problem. At least I can't find any. Maybe I can ask authors. So I saw that somewhere. Okay, writer was. I don't remember his name. Siguan. I remembered his name. And then testers are Misov, Ivan, Makoto. So I will maybe try to reach to one of these guys to get the editorial or at least some hint. But this was the hard problem since nobody solved it. What else? Maybe the last thing for today will be to check this blog on CS Academy. Thank you, Nulu. But the question is also how boring it is for you if I do what I did today for most of the stream. So I've read about segment trees and Gaussian elimination. I will be very glad about some feedback from the chat right now or later in the comments or Facebook, Discord. So what do you think about this? Do you learn anything this way? Should I do something different? Maybe in the future I will also watch YouTube videos about those algorithms. That just today I didn't want to mess up again with my audio. If there is no echo right now, let's leave it this way. It's fine, yes. So sometimes, even though I don't want to do that, I start explaining stuff with my own words. What is bad if I just want to rate the educational content online? I should just read it from the start to the end and say what issues I see. Instead, I stop and start explaining it with my own words and comparing it to my code, what isn't necessary, but on the other hand, it's something for viewers of a stream. So maybe that makes sense. I just don't know how to combine that. Also, I need to do more videos for YouTube. I think maybe I will manage to weekly do a single interesting problem from Codeforces and to talk about it. This would be like 20 minutes video, maybe shorter. Okay, but now let's read this one last thing for today. So CS Academy explanation for segment trees. And is it better than the other materials? Change AX to Y, and this time we care about finding maximum. Straightforward solution. O of n for queries, sum or maximum, and O of 1 for a change. Then optimization idea. We assume that n is a power of 2. Okay, so we have this set custom input. Can I do here 6? Okay, so this is again, I would say, a retarded type of tree. If we want to have a leaf here, not on the same level with the bottom leaves. Segment trees, okay. If n is not a power of 2, the only thing that changes is that if you have an odd length segment, the left side will be of length. Yeah, I don't like that at all. So they need to build recursively as well. Okay, and then updates. We need to recalculate several segments. Let's now updating this one. Yeah, and the fact that we update going down and then like no, we don't update first. Current segment. Since the update position is in the right subtree, we update this segment recursively. So we don't change anything. This way we first find a leaf, then we go up updating, in like really updating. And that is, I think, not efficient and hard. Then query. Okay. So I think this is a hard thing to do. Oh, by the way, here we can't go deeper to editorials before 7.10. So I have no idea how to find editorial for that 5.2.6. How to implement a logic into code. So your question is how to code? Well, you have to know the language, and then you have to express your thoughts with this language. It's like a question how to write words. If you know how to do it, then you do it. Then otherwise learn coding. If it's about general questions, how to efficiently code, then it just comes with time. Solve a problem every week or so. This would be really useful. You don't have to explain all the solution in details. Just say the general idea and the rest we can Google it. Googling isn't always a good thing in like parts of a solution. If I want to create an editorial about some problem, then I think it's better to really talk about this problem. I think explaining something could be better. Yep. We can already read the topics as you mentioned in the blog before, so we can tell some advanced techniques. Yeah, but also I don't know so many advanced techniques. There are not so many things that I can do videos about. It's easier for me, and I can do it for a longer time, to just take a nice problem that shows some nice technique every week. Explaining it that applied to code must be useful with some non-trivial problems. So this was a stream sponsored by Nutella. Not really sponsored, but here you go. Do I want to do something else today? So I did this too. I didn't practice Burnside's lemma. I upsolved this problem. I've read iOS syllabus. So everything other than that. And these are two more general things. So today I didn't touch code forces comments, what I did in previous streams. Programming stream. I saw this guy's stream, but he didn't explain stuff in English, at least, so it wasn't that interesting for me, but it's a cool initiative anyway. Zero XOR subset. This looks like Gaussian elimination. Yep, Gaussian elimination. Maybe I should read that. We're given an array. Your task is to divide the array into the maximum the maximum number of segments in such a way that each element is contained in exactly one segment. Each segment contains at least one element. There doesn't exist a non-empty subset of segments such that bitwise XOR of the numbers from them is equal to 0. Okay. I think we should transform this array into a sequence of prefix XORs. Then it's about choosing a subset of that, the independent linear. So I guess it will be just that. Let's see. Maybe I can read the block. Yeah, so they also care about XOR, prefix XORs. Okay, so he knows how to choose size k, because this is what Gaussian elimination does, and then what else? And then it's about the understanding what Gaussian elimination does, how to use it, in fact, to also get those places where we have values to take from. My approach would be to start with an empty matrix, then add a new number if it's not linearly dependent from the other ones, and that should be fine, I think. Yep, it should be. Basic decomposition. So this is just about understanding Gaussian elimination. Nice. Where do you live? In University of Warsaw Hostel. Just curious, what about those books? Are they about programming texts or some novels? No. I have some programming books, but they are in a drawer. I don't have them visible, so they're just some novels. Nice question about on Gaussian elimination. Yeah, I think that this problem is nice. It's a nice example talking about how to use the binary version of Gaussian elimination. So I will later think about details of that one. Also, let's check. So Hero Killer says that he also does streaming, but of Div2 contest. I can check you out later. I hope there are some comments in English. I see here that it's Russian/English. And well, good luck with your initiative as well. I think it's awesome if a lot of people do something for a community. Okay, this will be the end of today's stream. I guess the first part of the stream I will remove because it was just me fixing the audio issues and solving that C problem, but not so quickly. So I see no reason to leave it online. Next stream, I guess, in around a week. Before that, I will try to do some YouTube videos. And thank you all for watching. Subscribe if you haven't already. Like the video, tell your friends if you know someone who would like the content as well. And see you next time. Bye bye.